Hey, it's Sean. Today I'm going to teach you a little bit on how to import ChemCAD files, and in the future videos we're going to go through some regular expressions to figure out how to manipulate them into values that we can use, and then eventually go through class definitions to create an equation to calculate vapor pressure. Alright, so to start off here, we're going to import our libraries. So first things first, it's going to be requests and re. So those are the two things we're going to need for just this initial pull. Important, we're going to grab our base URL, which we're going to be using another GitHub user content. We're not going to be pulling directly from a GitHub, or not GitHub file, but ChemCAD, which to save and avoid licensing issues, and now you don't actually have to have it. Just use this URL, this GitHub user content. Specifically, we're going back to using this prof teach kids. And we're going to pull some very specific data, however we're going to leave it. So we're going to get this base URL, we're going to have the suffix. So this is the very end of a URL. And we're essentially telling it at the very, very end of the URL, we want everything that looks like this. Everything that is a props.txt file. So our comps is going to be our components. So what are we looking for? In this case, we're just going to look at water. So we're only going to have one component, and then we're going to try to find all the properties of specifically water. Okay, so now that we have all this, we're going to look for, what properties are we looking for in this component. So if we look at it, so we're going to go to GitHub and we're going to look at so here we are at the GitHub for one of my professors. So now we're going to go into data. So now we have all these props, Let's go down to water and see what this looks like inside. So, woo, okay. We have a lot of really long and apologies for the stop, some technical issues there. So back to what I was saying, we have these properties of water, and we have things like critical temperature, pressure, volume, and these values. So as you can see, for some of these we have a name, and then this colon, and then a number, and then for some of them we have units, for others we don't. So to try to pull this data, pull this information out, we're going to go back into our file. So now we can pull specifically the properties of water as our component or comps. So to better understand what we're pulling out, we're going to pull out very, very specific files. So to get this, we're going to go for single properties, and we're going to create a dictionary for them. So dictionary is these clearly with the edge brackets, and we want specifically molecular weight. And we're going to redefine that as quote MW, and comma, bring it down, and we're going to do the same for critical temperature. And critical pressure. Excuse me while I circle through. And then we're going to go through critical volume. So we're pulling out the critical properties, which is incredibly important for calculations resulting with vapor pressure and equation of state calculations. So for those who don't know, there are several different equations of state, some of which are the Peng-Robinson equation of state is a really common one. We also have the Redlich-Kwong, and then the new version of Redlich-Kwong, or SRC or SRK. We can go through these in a future video. However, right now we'll just talk about how to get all this information and then calculate or do some basic calculations with a little bit more about dictionaries and how to run some of these. Excuse me. I'm actually going to pause the video now and complete the list, and then once we pull it back up, we'll continue to talk through and go through some of how to go from this list and then look at the single properties and understand everything that's going on. Alright, so I'm back. So what I did was I finished our little library of lists. So these are all of our single properties. So if you remember in the .text file, there's these all the single properties are the ones that we care about, that are just this title, spaces, colon, and then these values. So these are all the single properties, and we pulled out the ones that we will care about for some of our future calculations. And as we scroll down, we can see that some of these are larger variable properties. So liquid density, and then using some equation as detailed by ChemCAD with this temperature range. We have these coefficients. The one we're actually going to get through for this one specifically is going to be vapor pressure. We're going to go through this calculation on how and create values and a whole set to understand and get all of these coefficients and pull them into our Python file, and then run calculations based off of those coefficient values. So as you can see, we're pretty far into this. In the next one, I will explain how to do regular expressions, so how to pull values like the ones we have here and the ones we have here. So the single properties and our coefficient properties. I'll show you how to take those from what they are now, convert them from string values to what we want to see. So we have all of this together, and we'll expand our library to go from single properties and coefficient properties to our larger scope. So I'll see you in the next video.